Hi, Ben with Novalex Stereophonic, and this is my bench. This is where I do all the repair and restoration work on the equipment that you see on my channel. I've been fine-tuning this bench over a number of years, and I finally got it to the point where I'm comfortable with the workflow and I have all the equipment that I need. So I thought it'd be a good time to show off the bench. So in this video, I'm going to go over all of the equipment that I use, a little bit about how I constructed the bench and the patch panel, and my workflow for servicing audio electronics. So if that sounds cool, stay tuned. Let's start out by talking about the bench itself. So the base of this bench I got from a company called Global Industrial. They specialize in equipment and supplies for assembly line, production, warehouse, stuff like that. So this bench is a steel base that can be put on wheels. There's a couple options that you can get. So I got a couple pull-out shelves, which we'll see a bit later. There's vertical uprights on it that support cantilevered shelves. So I have a shelf here and a shelf here. And then I have a bar running across the top, and they make these little removable bins that kind of just hang on the bar. So that's where I keep all my chemicals. What else? So lighting. So you can get this light that hangs off the top as part of the kit. It comes with like a standard LED, but I didn't really like the color of it. So I got this little RF LED remote kit, and I can change my color, temperature, and brightness with this remote. And then it remembers it, so when I power on and off the bench, it will keep that setting. I also have another LED strip on the same color controller that's mounted underneath here, which just points straight down to kind of light whatever equipment I'm working on. And then additional for lighting, I just have a, one of these magnifying lamps that's hooked onto a mount on the bench, so I can swing that in and out as needed. So that's the base bench, Global Industrial, great product. Solid butcher block top, which I love. You can get it in multiple angles here. I got I think they call it the bullnose front, which is rounded, which is nice. You can also get it square, which is nice if you're butting two benches up together in like a 90-degree configuration. But I like the rounded just so that if I'm leaning on something soldering, I don't have that sharp edge pushing into my forearm. So that's the bench. Next up, let's move on to the patch panel here, which is kind of the heart and soul of it, and that'll also explain the second level shelving that I built up here. Okay, before we talk about the patch panel itself, I wanted to go over some of the design concerns with this project. So I'm based in New York City and I've got very limited space, so I needed to be conscious of having everything compact and efficient. So what I did is I used a software I really like called Lucidchart, and I created scaled representations of each piece of equipment and laid them out on the bench and experimented with a couple different layouts, and this is what I settled on. The reason that I have an angle here is because this bench is right up against the wall. Angling these things out did two things for me. It gave me some depth for the equipment that I was going to mount in the two rack rail areas, and it also made it so that I can reach both sides without having to shift in my seat. So I'm 6'3" and I've got pretty long arms, but it's still kind of uncomfortable to have to roll around in a chair to make connections. So with this slight tone, I can reach everything when I'm sitting in the center of the bench. The way that it's constructed, it's just a piece of plywood that I marked and cut out. Originally, I laid this all out with cardboard just to get the the feel for it and make sure I got the angle here correct. And it all ended up really nice. So it's just made out of oak and some plywood and a couple standard rack rails that I just cut. I think I had some extra Mid-Atlantic rack rail. All right, let's jump into the patch panel itself, and that'll kind of explain why this is laid out the way that it is. All right, let's start from the top. This is my dummy load. The way this is set up is I have two precision 8-ohm non-inductive resistors, and there's a temperature sensor on one of them that's connected to a sensor that turns on a fan when they get above a certain temperature. So if I'm really cooking something at full output power, doing a distortion test for a couple of minutes, sometimes this fan will kick in. And when that does, I know that it's time to turn down the wattage and give the load a bit of a rest. So that's kind of like a double whammy. It starts to cool the resistors, and it also gives me an audible indication that the resistors are getting hot. I have a direct connection across each resistor that goes into my distortion analyzer. I also have a 10x output on each channel that's adjustable here. That just gives me a 10x input for the scope, so I view the waveform a little bit more efficiently. This switch here toggles in a relay that is connected to my amplifier and the speakers. So when it's in the down position, my speakers are basically available to have anything connected to them. When I flip it in the up position, it just links my power amp into the speakers directly. Those are my bench monitor speakers. This panel here is all made up of BNC pass-through jacks. So these just look like this on both sides. So on the back side, we'll see a little bit later, I just have terminated BNC connections that come in and pass through. So the way that I've set this up from left to right, I have the two outputs of my signal generator. So the outputs of this start here, they go through the back of the bench and they land at this part of the panel. From there, it gets split, so I can get my channel 1 test signal duplicated on a left and right RCA jack. And this also gets fed into this balanced line converter, which I've modified to give me a precision balanced signal that's available for me here. So that's signal generator connections. This is the PA81. I'll go into some more detail on this later. This is one of my favorite pieces of test equipment. And I have the output from that. It has like a scaled scope output that auto ranges. So that comes down here, and I have that plugged into the left and right input on my Chinese O1 scope, which I love. It's a super cheap scope, but it has a giant screen. So I use it all the time. These are my function outputs from the distortion analyzer. So if I want to, the downside of having a digital distortion analyzer that's showing you like percent THD plus N is you don't get a visual. On the analog meters, you can see yourself coming through a peak on a needle, but on a digital distortion analyzer, you don't get that. You're just looking at digits, and it's kind of hard sometimes. So this function output allows me to get a visual representation on an oscilloscope of the distortion, and that's super helpful for aligning like discriminator coils and stuff like that. So that's available for the distortion analyzer to get hooked up to a scope. So sometimes I grab one of these and just move it over. So say I want my O1 channel 2 to appear on the distortion analyzer, I can just remove this and put it here. And now I'll be able to view the distortion analyzer's function output on this oscilloscope. So I like this because it gives me a little bit of flexibility. It kind of always has its base configuration, and then I just change it as needed. So that was the distortion analyzer. Next up is the 4-channel scope. Initially, I had this configured with all 4 channels here, but once I incorporated the distortion analyzer into my workflow, I kind of rearranged it. So I have the first 2 channels of the 4-channel scope. One of them always gets fed directly from the dummy load. So this is channel 1 and channel 3 here. The reason I do it this way instead of using channel 1 and 2 is so that I can get the maximum performance out of the oscilloscope. On the 4-channel siglants, if you turn off channels 2 and 4, you get a little bit more or a little bit better performance on channel 1 and 3. So you're basically running it in 2-channel mode. The connection here is where I come out of the dummy load and feed the input of the distortion analyzer. So those are permanently connected. And that kind of takes care of everything that's labeled. This one is not in use right now. This is for future. And this one I have connected to an antenna. So when I'm doing a tuner alignment, a lot of times I jump between my my FM signal generator and the actual antenna for testing. On the next row down here, I have a DAC output and balanced. So I have a little Sonos Connect up here that I use as my bench source. So I just open up my phone. If I wanted to test a balanced preamp or something and listen to it here at the bench, I would bring up something on Spotify on the Sonos. It runs through the DAC, and then I get a very nice, high quality, balanced audio output there. This we already talked about. That's balanced audio from the signal generator. These are blanks for future. This is interesting here. Sometimes I want to see a balanced signal on the oscilloscope, and the way that I do that is I have this little jack here that accepts a balanced connector, and it breaks it out to B and C. So this is pins like 1 and 2, and then the other one is pins 1 and 3. So if I wanted to view a balanced signal on the oscilloscope, I could come right out of the back of a preamp and get it into my system this way. So that's what these are for, is looking at 4 channels of balanced audio at once, or 2 channels of balanced audio, the plus and minus swings, or inverted and non-inverted. So that's what that is for there. And I may have to incorporate extra balanced stuff at the bench here. I work on a lot of high-end audio equipment, and I kind of just needed connections for everything. This XLR to RCA gets fed back through this device, which I'll talk about in a little bit more detail when we get down there. All right, next up, this is all my keystone connections. So these are panels that you can get that use an industry standard insert called a keystone, which is basically just a square-shaped spring-loaded clip thing that you can clip in and put all these different ends on, or you can order all kinds of different ends. So I have the output of the Sonos down here, optical and coax. So I've got my digital outputs from the Sonos down here that I can loop back into the DAC. So these are DAC inputs. This I'm not going to go in order because it's a little bit confusing. This is single-ended coming out of the DAC. So that's like this, but in single-ended. This, again, is my signal generator output. This here is going into my FM signal generator. This is so that if I needed to actually listen to a precision signal or feed like a test signal into my RF generator, I could feed like a precision square wave or something in if I needed, or actually even listen to music and make a radio station with my Sencore PA, or what is it, SG80. This I don't have set up yet. I don't do a lot of turntable work, but eventually I'm going to have a phono stage here so that I can plug a turntable in, either MM or MC, and interface with a phono stage. This here is an inverse RIAA filter. So what I do a lot of times is I will feed a test signal from my signal generator into this inverse filter, and then it comes back here and I can feed this into a phono stage. So I use that a lot if I'm testing like a phono preamp that's built into a 2-channel preamp. This is where I plug into the PA81 to measure audio signals. This is an input for my Macintosh bench amplifier up here. This we already went over. This is where the speakers connect in. This is another connection for the PA81, so that interfaces with the dummy load built into the PA81 device. This is how I plug into my dummy load. And this is the output of the power amplifier. So this would be like if I'm troubleshooting a blown tweeter or something, I could connect it here and access it on my power amp and get a signal fed into it. This is just for future. I don't have anything in this slot, so I just put a vent there. And then the final device, this is a Tascam LA-40 Mark II. Its function is to convert balance to single-ended and single-ended to balance, but I've modified it slightly. So the way that I've incorporated the Tascam here at the bench is I've modified it internally by changing the connections on the XLR jacks so that I can get a precision adjustment on each one of these trimmers to give me an exactly equal positive going and negative going half of a balanced signal. So I'm just basically using it to convert single-ended to a precision balanced signal with op amps. And then I also use the balanced to unbalanced feature in it so that if I'm testing, say, a high-end preamp that only has balanced outputs and I want to listen to it on my single-ended power amp, I can feed the output of that preamp in here and it will come out to me on this XLR to RCA jack to get fed back into the power amp. So that's where I use that if I need to listen to something that I'm testing here at the bench and it only has balanced outputs. This is what the patch panel looks like from the back. So all the connections on the scopes and test equipment come down, they land on these rails and they get labeled and dressed into their appropriate jacks. And then my inverse RIAA filter is here. And the temperature sensing dummy load and relay devices are up top. So the other equipment that's part of this slanted section is my bench amplifier and the Rotel DAC, which I already mentioned. Now I know having a Macintosh at the Workbench is a little bit overkill, but I got a really good deal on this unit and I really like its features, so that's why it's here. The main reason that I like this amp as a bench amp is it has individual attenuation for each channel. It has metering and I can toggle on and off the speaker protection relay. So what I do a lot of times, say I'm testing a preamp for the very first time after fixing it, everything's passed on the scopes, but I'm plugging it into an amp and speakers for the first time. It's nice to be able to slowly ramp this up and make sure that I have a signal going where it's supposed to go and then I'm not getting any like terrible spike or anything like that. So this allows me to check and make sure my signal's good before I toggle in the speakers. And then for the Rotel DAC, it mostly just stays set on the coax setting. I do on occasion use this if I have a CD transport that I need to test or something like that. But its main function is just to get me my single-ended and balanced audio output from the Sonos Connect. Moving along this main row here, this is right at eye level. So the scopes are what I use the most often. They're basically always on when I'm at the bench looking at some signal or another. The left scope is my cheap Chinese O1, which is almost always permanently connected to my PA81 Sencore analyzer, which I'll talk about in more detail when we get up there. But the bottom line on that is I use the PA81 so much, it's justified to have a dedicated scope just for that device, and that's what I use the O1 for. For the Siglent, this is the SDS1104X-E. That means it has Ethernet capability. I connect it in conjunction with the Siglent signal generator, and that allows me to do Bodie plots. So basically this device will tell the signal generator what frequency to output, you feed the signal generator back in, and then you can do a 3-channel Bodie plot, which is nice. I've done a video with some crossover analysis and looking at frequency responsive power amplifiers in 2 channels, so it's a pretty nice feature. I use this for monitoring the output level across my dummy load when I'm measuring power amps. I use it for looking at balanced input signals, signal tracing, basically everything else. So this is my workhorse scope. Moving over here, I don't have this on right now, this Panasonic, because it's got such a loud fan in it, but this is a very nice distortion analyzer with a extremely low distortion oscillator. So this is very good for getting very accurate measurements of distortion and comparing them to spec sheets. So whenever I fix one of those giant monster receivers, I'm verifying its distortion specifications with this device. We already touched on the signal generator. I like this signal gen. This is the SDG 1032X from Siglent. It's just very fast. The data entry on it's really good, so I can just go waveforms. I'm constantly switching between square and sine. Adjusting the amplitude is extremely easy. You can use the rotary to sneak up on the clipping power of an amplifier. So just a really nice oscillator in general. The distortion on it's not very good. It's about 0.08%. So I can't use it for distortion analysis, but as a function generator to give me squares, sines, pulses, stuff like that, it's great. And then I have the matching Siglent DMM, kind of the same series, so they look nice together. I don't use this a whole lot because I have a couple of Fluke 87.5s, which are my workhorse meters, but it's nice to have this when I need a bunch of meters connected simultaneously. When I'm setting bias on 2 channels and looking at DC offset simultaneously, it's nice to have another meter. And also it allows me to do the 4-wire ohms with Kelvin clips. So that's what that meter is usually for. Down here is the soldering equipment. So I'm a big Hakko fan. This device saves so much time. This is the FR301, I believe, and the FX888D soldering iron. Both very good devices. I might upgrade eventually just because I'm here soldering every day, but I really haven't found a big downside to them, except this thing's kind of big, but it does a really good job and it's pretty easy to clean and maintain. So that's the Hakko stuff. These 2 devices here, or like this area, is what I use for managing my devices, power for devices under test. So this is a Sencore PR570. What this allows me to do is basically an isolation transformer and a variac in one box. Its limitation is that it's only 5 amps, so I can't test giant power amps with it. But when I'm powering something on for the first time, I usually use it. It has a trip set, so you can set how many amps you want it to go up to before it kills the output. So I could set this at 2 amps, for example, and then if my device under test ever starts drawing more than 2 amps, it's going to cut the power. So it's nice to have that. It also, you can plug in a probe and do like analysis of, see if there's any leakage to the chassis or anything like that. So it's nice for that. Behind that, this output gets plugged into this box here. So this is my very easy on-off switch. So if I'm testing something and it goes into thermal runaway or something, and I'm seeing it draw a lot of current, I can very quickly slap this switch off and turn off the device under test. The orange outlet is behind a dim bulb, and this one is full output power, and I also just have a kilowatt on this. This is fairly accurate, but it's not as accurate as this guy. So I usually have this on my main dim bulbed output, I guess you would say, and then this one is just a straight dim bulb. So I have a little fixture over here that holds my dim bulb connection. So that's not seen a lot on camera. I'm always looking at that off to the left. Other things over here, this is a button that toggles on and off my fume extractor. So I got the big Hakko fume extractor with its head over here. This is another thing that was like a very good investment. As a full-time technician, I need to be conscious of how much solder fumes and chemicals I inhale, so it's nice to have the nice fume extractor there. And then this is a solution that I came up with for the FR301, which I really like. So one of the downsides of this guy is once it's powered on, it will not turn itself off. There's no like a timer that turns it off. So if you forget to turn it off, it's just going to sit there for days. So what I ended up doing is I put in this little timer. So I can click this box, it'll turn this on for an hour, and then it'll cycle it off. I can go, it's 15 minutes, 30, 1, 2, 4, and 6 hours. And what I use it for a lot is I'll just click the 1 hour button, and as I'm working on something, I will hear the relay and that little timer click off, and it's just a reminder that an hour has passed. So it kind of gives me a reference of how long I'm spending on a project. Sometimes I get really deep into something and and forget that I on the clock here and I need to get this thing going. So it's nice to have that as a little reminder, and it keeps me from accidentally leaving that desoldering station on. So that's about it for the bottom area of the bench. Next, I'm going to go up and review my Sencore collection. All right, let's go through the top row here. This is a Siglent SPD3303X-E power supply. I really like this power supply. It has everything that I need: current limiting, channel tracking. You can series the two outputs together for more voltage. I use it a lot for testing lamps, doing LED modifications, powering up breadboards when I'm doing little custom circuits and stuff. So it's nice to have a bench supply. I didn't for a long time, and now that I got it, I will never be able to go without it. Next up, Sencore LC102. This is a great capacitor tester. That's my main use for it. It can also do inductors and a few other things, but I use it primarily for leakage testing on large electrolytic caps. So like on those big Pioneer amps, I always disconnect the main filter capacitors and test them at 80 or 100 volts, whatever they're rated at, and make sure that they don't have excessive leakage. If they do, I pull them out and replace them. This is also good for finding leakage in old like paper caps and stuff like that. So that's that device's main function for me. The next up is the Sencore PA81. If someone asks me what's your favorite piece of test equipment at the bench, or what's the one thing that you couldn't really do without, for me it's really the PA81. Not because it's essential, but because it speeds everything up so much. So the PA81, a lot of people just think of it as a dummy load for testing output on speakers, because one of its functions is you can put it into watts mode and you can measure output power directly with this needle and the various ohm selections here. But that's not its main function for me. I use it so much more for the audio lines measurement purposes. So there's a set of inputs on here that are loaded at 10K, and I use those for testing the outputs of preamps, phono stages, tuners. So like when I'm testing a vintage receiver and I want to verify the phono stage, I'll plug this into the tape out jacks and then feed a inverse signal into the phono stage, and I'll be able to listen to it, view it on an oscilloscope, and see metering. So it gives you 3-in-1 when you're using it. It's got little speakers that are built into the sides with volume attenuators here. And I use it all the time for tuner alignment. So I come out of the tape output jacks when I'm doing a tuner alignment, and I get a detailed look at the waveforms. I can hear the distortion as I'm tuning onto stations and what happens when I move my test signal to the left and to the right. So I use it on the audio lines function all the time. Another thing that I've been using it for recently is I go to the DC or AC volt setting and use this as a hyper accurate meter. It ranges itself down into these very low ranges, and you get extremely accurate needle movement. So I use that for like peeking out coils and stuff. I wanted to incorporate a VTVM here at the bench for the longest time, but I find that on most of the adjustments that call for a VTVM, I'm able to get a pretty darn good adjustment using the built-in voltmeter features on this guy. So that's the PA81. Like I said, I use it so much that I dedicate an oscilloscope to it. Moving on, we're going to take a look at the Sencore oscilloscope that I just got and the SG80 RF analyzer. Next up here, I have a Sencore SC3100. I'd been wanting to get an analog scope for the bench for a very long time. Up until this point, I had been using a little Tech 2-bay scope, an SC scope that was inside of a mainframe, and I would just leave the frame at the side of my bench and pull it up whenever I needed it, but it was kind of inconvenient, so I didn't use it a whole lot. Now that I have a analog scope dedicated at the bench, I use it a lot. It's very good for certain things that digital scopes just can't do. So I use it a lot for, I've got a few test jigs that use XY mode, like an octopus tester and things like that. This works great for that. It works really well for looking at the function output on the distortion analyzer. I use it for the sweep functions in tuner alignment on the SG80 and a handful of other things. So now that I have one at the bench, it's really nice. And the reason that I went with this one was I already knew that the Sencore equipment fit the depth at my bench. So when I got it, I knew it was going to be the same depth, fit on the shelf well, and it matches well with the other Sencore equipment that I have up here. This is the SG80. This is a very nice AM/FM signal generator with multiplex. it's specialized for doing like consumer level tuners. Some of the HP stuff, it can do a little bit more than this, but this gets me, you know, to anything that I'd need to do on a vintage receiver. The only beef I have with this piece is it doesn't have a 19 kilohertz output, which I'm thinking about going in there and modifying and finding where the 19 kilohertz oscillator is and pulling that out onto a BNC on the back or something. But up until this point, I've been able to work around that. I really like this device. As somebody that works on receivers, it's kind of a must to have a good FM generator. So that's what I use that for. On the very top row here, I just have a pair of Totem Mite speakers and then all my chemicals and a bunch of other little accessories and things. So that's most of the bench tour. What I'm going to go over now is kind of just what I have inside of the drawers, some of the little other test equipment auxiliary stuff that I use around the shop. This is the pull-out accessory drawer that I got when I got the Workbench. I have a couple obligatory Fluke 87.5s in here, ProbeMaster probes, keep all my ends in here. I've got a couple other accessories, B&K LCR meter, little double thermocouple, some Chinese job. And then I converted my Fluke 115. I used to use this a lot on the bench. Now I have it dedicated as a capacitor drainer rig because it's got fast auto ranging. The Global Industrial Bench has a bottom shelf down here, which I use for a bunch of storage. So I've got a few drawers down here that we'll look at in a second. I have a Amplitrex AT1000. I'll pull that out quick. We'll put it up on top so we can take a closer look at that. Amplitrex is great. I've got a drill down there that I use a lot for the chassis work that I have to do once in a while. Let's take a closer look at the drawers down here. These are just drawers by DeWalt called T-Stack that I've kind of just customized here. This first drawer, I just keep some files, caliper, heat gun, stuff like that. Got some Dremel stuff up here. My heat shrink stash, so I keep heat shrink and tubing and stuff in here. Got a couple small pieces of test equipment in here. This is one of those Chinese universal component testers. This is another indispensable piece of equipment. I got this octopus tester on eBay a while back, and this thing has saved me many times. When I've gotten very stuck on things, this has been the thing that's cracked it. So if you don't have an octopus tester, if you've got a nice analog scope, this is a great thing to get. Very helpful when you have an issue with an IC or something strange that you can't track down. It gives you a visual indication of failed components, so I really like that. In the other drawers, I just have a bunch of BNC adapters and razor blades and stuff like that. I use an Amplitrex AT1000 for tube testing. This is a great tester. It's very expensive, but for me, having something that was compact and reliable was the plus. It can't test every tube type, but it tests almost every audio tube, and it does a very good job at matching plate current on output tubes. It tests for plate current and mutual conductance on every one of its tests. It tests the output tubes. You can test upwards of 450 volts on the plates, so you can get a really nice, accurate in-circuit analog. So I really like this tester. I use it all the time. Can't say enough good things about the Amplitrex. So that's that. Other little stuff that I have around. I keep a few of the Atlas devices, Peak Atlas. So inside this little Pelican case, I just have the ESR 70 for testing ESR and value on small electrolytics, and then the Atlas Zen for checking Zener diodes. This is a great device. So that's kind of just a little auxiliary box that I have laying around. What else? You might have noticed I have a bunch of tools just randomly hanging around places. I have a couple magnetic strips. So up here is where I keep all of my my pliers, screwdrivers down here. I have some strippers and other stuff on a couple other magnets. Over here on the wall I have some wires, some additional tools. That knife up there I use when I'm cutting huge pieces of foam when packing. So that's great. Oh, I missed the Yugo. I used to own a Yugo. It's known as the worst car ever made. I have a little Lego representation of that guy here. You might see that on the channel once in a while. All right, there's not a whole lot left to look at here. What I do want to do is pull the bench away from the wall and show some of the wire duct and stuff that I use to keep things clean. But before that, I'm just going to take a swing up and show you my part storage. I'm lucky to have very tall ceilings here, so I'm able to go really high with a baker's rack, and I keep all of my parts in these little containers. They fit Mauser bags really well, so that's how I deal with storing a ton of parts in a very small space. So So this is what the bench looks like from the back. So what I've done is I've put a piece of finger duct at each one of the shelf levels, and then I've got power strips strategically located in different areas. So there's one power strip here, one up here, and that allows me to keep my power cords nice and short going right into a power strip. And then if you look down here, you can see the signal cabling kind of comes in from the devices, crosses at 90 degrees underneath the power. I'm basically just trying not to induce any hum onto my signal cables, because I do have some pretty long runs coming back to the patch panel. So all the devices, cables get routed into these finger ducts. They come this way and either connect into an associated piece of equipment, or they run into this duct, go down, and then out to the patch panel, which we looked at earlier. Okay, I guess that about does it for the Workbench tour. If I missed anything or there was something that you wanted me to spend a little bit more time talking about, just let me know in the comments. I'll try to respond. I'm hoping that this can be helpful to anyone that's looking to maybe revamp their bench, buy a new piece of test equipment, something like that. So if you're curious about anything in here and you have questions, please ask. Again, I've been working on this over a few years, and I think I finally got it exactly how I want it, but it's probably going to change. It seems that I buy a new piece of equipment every year or so, and then I need to rearrange things. So it's February 2024 at the moment. I will probably end up releasing videos in the future when I've revamped something or found a new way to measure something, and how it works into the patch panel. So thanks again for listening to me ramble about my Workbench. If you like this content, I encourage you to subscribe to the channel and check out some of my other vids. Thanks again. See you later.